We're going to go ahead and take a look at section 6.2, which deals with multiplying and dividing rational expressions. So we have about 4 examples that we're going to run through. Again, I encourage you to peruse through the examples in your textbook. And if you need additional help, please go ahead and seek out additional videos that you could probably find pretty easily on YouTube by typing in multiplying and dividing rational expressions. So the first problem that we're going to look at, we're just going to look at straight multiplication. And as a brief review, if you have something like a over b times c over d, how do you multiply fractions? And to answer that question, what we do is we multiply straight across. Okay, so we will just exclusively multiply the numerators together, and that would give us something like a times c. And then we would multiply the denominators together, which would give us b times d. So in this case, we would go ahead and you can either start canceling right away, or you can kind of write this all under one giant fraction. Very similar to what I have noted in blue on the right-hand side of the screen. So I have x cubed times y times x times z cubed times y times z, all over z times x squared times y squared times x times y times z. So if you notice, your variables are kind of scattered everywhere. So I want to go ahead and clean those up. So what I'm going to go ahead and do, I'm going to see how many x's I have. So if I have an x cubed times an x, that's going to give me an x to the 4th. Okay, that is pulling from your product rule of exponents. If I'm multiplying two values that have the same base, I add together their exponents. Also recall that since you have an x cubed, your other x has an exponent of 1, hence why I have x to the 4th. 3 plus 1 is 4. Let's go ahead and take a look at our y values then. I have a y times a y, so that would give me a y squared. And then lastly, I have a z cubed and a z. So z cubed times z gives me z to the 4th. So I'm just going to go ahead and clean that up. And now we start the process all over again. I have an x squared and an x. Well, that will simplify down to, or it would multiply into an x cubed. Then I move forward with an a y squared times a y. And this gives me y cubed. And finally, I have a z times a z, which is z squared. What you should notice at this point is this is very similar to problems that you dealt with in Chapter 4, where we were just simplifying expressions, with exponents. So note here that I have an x to the 4th over an x to the 3rd. That simplifies to just an x that will sit in the numerator. And again, why would that be? Because in this case, I have more x values located in the numerator than I do in the denominator. Then I move over to the y squared and the y cubed. Well, how many y's would I have left if I were to reduce this down? I would have one y, and because the exponent is larger in the denominator, that's where my one y will be placed. Okay, and lastly, let's take a look at the z's. I have z to the 4th over z squared. Well, remember, this is your quotient rule, so we've been using the quotient rule as we've been reducing. So if I have 4 z's in the numerator and 2 z's in the denominator, that's going to leave me with 2 z's in the numerator after I reduce. So my question to you then is, am I done? Can I reduce anything down? The answer would be no, so that is your final solution. It's as simplified as possible. Now let's take a look at the division problem. So again, just as a quick refresher, if I have a fraction divided by another fraction, how do I contend with this? Well, I can rewrite this. So I can skip the first fraction. In other words, I'm just going to write it exactly as I see it. I'm just going to rewrite it. Then I'm going to move over to the next fraction, and I'm going to flip it. In other words, I'm going to take its reciprocal. I'm going to swap the positions. And by doing this, I get a multiplication problem. So then I get AD over BC. I can do the exact same thing here. So in this instance, I'm going to skip my first rational expression, or my first fraction. I'm going to flip the second fraction. So I'm going to put 6z in the numerator and z minus 2 in the denominator. And that allows me to make this a multiplication problem. So if you guys notice here, I can actually start canceling out. So I have a z minus 2 in the denominator, and I have 2 of them in the numerator. So I can cancel one out here along with one of them here. So this is going to leave me with a z minus 2 as part of my answer. Next, notice that I have a 3 in the denominator and a 6 in the numerator. I can cancel and reduce that down to be a 2. So that's going to leave me with a 2 here. And then finally, I have a z squared in the denominator and a z in the numerator. Well, again, I can get rid of or reduce one z out of each, and that leaves me with just a z left in the denominator. So usually how we write these, we usually write just a constant value in front of a quantity. So we can go ahead and do that. You could also present your answer by distributing the 2 into the quantity. So we have 2z minus 4 all over z. So recall that you can't reduce any further because each term that you have here does not have a z in it, so I can't reduce it with the z in the denominator. And that is it. So this is our final solution. Now let's do a little bit more heavy lifting. So whenever you guys are seeing something like 3x squared plus 5x plus 2, you should be asking yourself if you can factor that. So let's go ahead and try. So I can break a 3x squared apart into a 3x and an x. And I need to also go ahead and figure out how to break apart 2 and 1. For the sake of the timing on the video, what I would suggest doing is pausing it and trying to finish factoring this out and then coming back to check. When you come back, I can only break apart a positive 2 in so many ways. And I can also use the context clues of the fact that my middle term is also positive. So I know that my signs will be positive. And I'm going to put the 2 in the first quantity and then the 1 in the second quantity. The reason being is if you check, if you did your outers, so 3x times 1, that gives you 3x, and then your inner from your FOIL, 2 times x gives you 2x. So 3x plus 2x would give us that 5x, or that middle term. Next, we're going to go ahead and see if we can clean up the denominator of this rational expression. Well, hopefully in the previous video, if you were paying attention, this is a difference of 2 squares. So I'm going to go ahead and break this apart. And again, I would suggest pausing the video to finish factoring this and checking. Okay, so then this becomes x minus 3 and x plus 3. Spend a little bit more time. And note here that x minus 3 is already in its simplest form. I can't factor anything out. There's nothing in common. But I am seeing that I have an x squared minus 4. So again, what is this? What is this special case? Okay, this is a difference of squares. And again, the tip-off is that you have 2 terms, and both of those terms are squared, and they're being subtracted from one another. Okay, then we move on to our next group. So really, we're going to do a little bit more heavy lifting here. So x squared plus 5x plus 6. So again, I should be asking myself if I can try to factor that. So x and x. And then since I have a plus 6 and I want my middle term to also be positive, the context clues tell me that both of my quantities will be addition. And I'm going to break apart 6 in this case as a 3, and a 2. Okay, again, you can check that by foiling that out and seeing if you get back to the original x squared plus 5x plus 6. If you don't get that back exactly, then you factored incorrectly, and you should go back and try again. And then the last one that we have, 6x plus 4. I can't FOIL it, but hopefully what you're seeing is you're focusing on the 6 and the 4. Both of those are multiples of 2. So let me see if I can just factor out a 2. And that would leave me with a 3x after I divided a 2 out plus a 2 after I divide the 2 out. And again, if you don't believe me, redistribute that 2 back to each term, and you should get back to 6x plus 4. So now let's see what we can cancel out. Do I have a 3x plus 2 in both the numerator and the denominator? Yes, so I can reduce it out. How about an x plus 1? Nope, I got nothing. How about an x minus 3? Yep, I got one of those, so that's gone. How about an x plus 3? Excellent, I have one of those too. And an x plus 2. Yep. So at this stage, you just want to be careful that you collect everything that you did not cancel out. So focus all of your attention on what's going on in your numerator first. The only thing that's left over, or survived in this case, is an x plus 1. And what I have left over in the denominator would be that constant of 2, and then that x minus 2. Since everything is already factored, we can kind of clearly see in this case that nothing else can be reduced out. I don't have a 2 in the numerator and in the denominator to cancel out. I don't have an x plus 1 in both numerator and denominator to cancel out. And I don't have an x minus 2 in both numerator and denominator to cancel out. So that is why this is my final answer. I've reduced it down as far as I can. And finally, let's take a look at one more. This time I'm going to combo my multiplication and my division together. So what I would suggest doing is pairing these off one at a time. That's one approach. So I'm going to spend some time looking at this group first. I'm going to take care of the multiplication first. I don't have to, but this is where I'm choosing to start. So x squared minus 5x. So first, let's take care of that. Well, I notice that they have a common factor of x, so I'm going to factor that out. And at this point in time, again, what I would suggest that you guys do is pause the video and try to work this problem out. I think by going through the first 3 examples, you have a pretty healthy idea as to how to approach these problems. Now what I would like you to do is try it on your own, come back, and compare your work with mine. Okay? So when you come back, we agreed that there's a common factor of x in that first numerator. So if I factor an x out, I have an x minus 5. Underneath, x plus 1, there's nothing I can do here, so I'm just going to rewrite it. Now I'm going to go through and multiply with my next fraction. Again, I have an x plus 1, so I can't really do anything with that. And then I have an x squared plus 3x. It's pretty similar setup to the first one that we were looking at. So there's a common factor of x that I will factor out. And that leaves me with an x plus 3. And then we still have our division over here. All right, so let's go ahead and cancel things out if we can. Well, I see that there's 1x and 1x. Those can reduce out. I have an x plus 1 and an x plus 1 that will go away. The x minus 5 and the x plus 3, they're not going to go anywhere. So let's spend a little bit more time and rewrite this. So I have an x minus 5 left over and an x plus 3. And that's all being divided by an x minus 5 over an x minus 3. OK, so kind of going through, let's note that this is a division problem. So what I'm going to do is I will skip the first fraction. I will flip the second fraction. So I will put x minus 3 in the numerator and an x minus 5 in the denominator. This makes it a multiplication problem. Can we clean anything out? Why, yes, we can. We have an x minus 5 and an x minus 5 in both the numerator and denominator. I cannot do anything with that x minus 3 and that x plus 3. In other words, I can't reduce it out. They're not identical. Because they're not identical, I can't reduce them out. Okay? I don't know if x plus 3 is going to be equal to x plus 3. If I knew that they were equal, then yes, I could reduce them out. But since I don't know what x is in this particular problem, I have to leave them there, just in case. So I have an x minus 3 in the numerator and an x plus 3 in the denominator. This is my final answer. So hopefully these problems were helpful in explaining these concepts a little bit more. Again, if you have any other questions or if you need more clarification on material, please come see me.